So the next topic in linear time invariant system, the graphical convolution. Suppose I have been given two signals, like let's say this is xt. So the signal is from, let us say, 0 to 4. Okay. Now ht. Let's say ht is from 0 to, let us say this is 10, this is 5. These are the two signals given. I want to find out yt, which is convolution of xt with ht. The formula is integral of tau equal to minus infinity plus infinity x tau ht minus tau d tau, which I have already derived in the previous lecture. Now yt. So I already derived the limits of yt, output limits, that is the extreme limits of output. Extreme limits are 0 plus 0 and this 4 plus 4. These are the extreme limits of yt. I have already derived. And remaining all cases, you will get output 0. Okay. So yt exists from 0 plus 0 less than or equal to t less than or equal to 4 plus 2. It is 0 to 6. Yt exists between 0 and 6. And above 6, you will get 0, output 0. And below 0, you will get 0 output. Okay. So these are the extreme limits. So now I want to show the graphical convolution of these two signals. Okay. First, in convolution, what we are doing. So this is the formula. This is the formula. What exactly we are doing here? So we have been given xt and ht. Okay. Then what we have to do? First, xt to x tau. That is, t is changed to tau. The time axis t changed to tau axis. And next ht to h tau. Next h tau to h minus tau. That is, this tau changed to minus tau. This time reversal operation on h tau. Next h minus tau to h minus of tau minus t. Right? This is h minus tau plus t. This is h t minus tau. So tau to tau minus t. Wherever tau is there, replace that tau by tau minus t. This is what I have done here. Here tau is there. I replaced tau with tau minus t. Then I got this one. Okay. Here, if t is positive, then we are delaying h minus tau. If t is negative, we are advancing h minus tau. Right? For example, small t is, let us say, plus 2. Then tau minus t, tau minus 2. Tau minus 2 means h of minus tau is there. We are delaying 2 units. That is, the signal move, the h minus tau signal move towards right side. Okay. And if t is negative, let us say t equal to minus 2, then we get h of minus tau minus of minus 2. That is h of minus tau plus 2. Tau plus 2 means h of minus tau. H of minus tau signal moves 2 units left side. If t is negative, h of minus tau will move towards left side. If t is positive, h of minus tau signal move towards right side. This is what we have to keep in our mind while graphical convolution. And this t, how to select this t, right? So the extreme limits of t we already known, because these are extreme limits. So this t must be greater than 0 and must be less than 6. Suppose if t is less than 0, then we will get 0 output. If t is greater than 6, then we will get 0 output. I will show these things also. So now come to the graphical convolution. So xt is given this t, this xt, t, ht. These are given. Xt is from 0 to 4 and ht is from 0 to 2, and this is given 10, this is given 5. Okay, so the first step is xt to x tau, tau x tau. So we are just changing the variable t to tau, that's it, but shape of the signal will not change. This is the shape of the signal, the shape will not change. What? 0 to 4 only. And h tau, this tau, h tau, same, 0 to 2. And the next step, h tau to h minus tau. This tau, h minus tau. H minus tau means we have to fold h tau about y-axis. This is 0, 2 becomes minus 2. This is the signal. Right. This value is, this is h minus tau, and then we have to shift by t units, small t units, either left side or right side, I don't know. It depends on small t value. Suppose let's say t is negative. Okay, so h minus of tau minus t. Let's say this small t is negative. If it is negative, this signal h minus tau moves towards left side. So I am assuming that this t is negative. So what you have to do? This. We have to add t to each limit, right? 0 plus t, t. So if t is negative, more negative, then it moves left side. T is negative, left side. If t is positive, it moves towards right side. If t is positive, right? Put t equal to some 4. You will get this value is 4, this value is 2. So the signal actually from 2 to 4. So this is 2, this is 4. Here, right? Put t equal to some minus 4. Then if t equal to minus 4, this is minus 4, this is minus 6. So signal is actually from minus 6 to minus 4. Somewhere here. This minus 6 and minus 4. This. So this shifting towards left side. Okay. If t is negative, the signal shift towards left side. If t is positive, the signal shifts towards positive side. Okay. So in the output, what we are doing, yft, we are finding out, we are finding yt, that is integral of tau equal to minus infinity plus infinity x tau h minus of t minus t, this one, and a d tau. This we are finding. So here we are multiplying these two, and then we are finding integration, that is the area under this multiplication. Integration is nothing but area only. So first we have to multiply them, these two signals, and then we have to find out area. Okay, so if we get 0 while multiplication, then we will get 0 output, right? So if we get non-zero in the multiplication, then we will get some non-zero output. So the extreme limits of yt, we already know extreme limits of yt as 0 to 6. So if we choose this t value such that if t is less than 0, then we will this multiplication, this the x tau and h minus of tau minus t, this multiplication will become 0. If t is greater than 6, this multiplication will become 0. Only the 0 to 6, 0 less than t less than 6. So that if this t is in between these two limits, then only we will get non-zero output. Then only we will get non-zero value of this multiplication. So that I will show here. Okay. Now let us say this is h minus of tau minus t. I will draw this x tau and h minus of tau minus t, one below the other. Then will be easy. This is x tau. X tau is from 0 to 4. 0. This is, let us say this is 4. This is the signal h tau. And h, this is h minus of tau minus t. That is h of t minus tau only. That I will draw below the h x tau. This is h of t minus tau. H of minus tau of minus t. Here. I am assuming here the t is negative. Here 0, this is t minus 2 plus t. So clearly this t is less than 0. Here the 0. Okay. So this t less than 0. Then we have to multiply these two signals, x tau and ht minus tau, right? If we multiply these two signals, we will get 0, right? So there is no overlap between x tau and ht minus tau. So we will get 0 here. Here it is 0. 0 multiplied by this signal, anything 0. And here it is 0 multiplied by x tau, you will get 0 only. So there is no overlap. So we have to find out where these two signals are overlapping each other. There you will get some non-zero value if multiply them. If there is no overlap between these two signals, we won't get any non-zero value if multiply them. I will choose this t such that these two signal can overlap each other. So now I am taking this t is greater than 0. This small t is greater than 0. Okay. Here I will choose this signal. I'm shifting towards right side. Okay. So shifting towards right side means this small t value will be positive. I'm taking like this here. So this point is minus 2 plus t and this point is t. This clearly showing the limits of t. Here the limits are t is greater than 0 and this minus 2 plus t is less than 0, right? So I have written this point which is less than this 0 value. So from this to t is less than 2. So 0 less than t less than 2. 3 equal to, you can put the continuous case. So this is the limits of t from minus 2 plus t and t. Okay. So if you multiply these two signals, what do you get? Multiply these two signals, x of tau, this is x of tau, this is h of t minus tau. So I will draw that below this. If I multiply these two, x tau and h t minus tau. Okay. So if you multiply these two, here it is 0, here 0, here it is t. So somewhere it is t. Okay. And this value is 10 and this value is 5. If you multiply these two, you will get 50 from 0 to t, right? So below 0 it is 0. Multiply anything With 0 you will get 0 below 0, and greater than t it is 0. Okay, it is 0. H of t minus 2 is greater than 0. If you multiply anything with 0 you will get 0. So only 0 to t the signal exists. That too 10 into 5 is 50. That I will draw here. 0 to t, it is 50. Okay, now in the last case we need to find out the area, that is the output, right? Yt is integral of tau equal to minus infinity plus infinity x tau h t minus tau d tau, right? This is the multiplication. This integration nothing but area of this multiplication. This we got the multiplication and we need to find out the area. This is the area, right? Find out the area. How to find out the area? This is the rectangle, so length into breadth. This area is nothing but yt, that is length is whichever, let us say t minus 0. This is the length, and height is 50. We'll get 50 into t, and the limits are, so these are the limits, right? These are the limits. Yes, 0 less than n, t less than 2. Okay, for 0 less than t less than 2, yt equal to 50 into t, right? For t less than 0 there is no overlap. So this is for t less than 0, there is no overlap, so you will get 0. If you want to write here, yt is 0 for t less than 0. Okay, next what I do, next I will shift this h t minus tau towards positive side again. So I will draw with another color, so that now again shifting towards right side, such that this width is very small than x tau, right? This is x tau, this width is 4 units, but h t minus tau width is 2 units only. So I will draw this x t minus tau such that its total width will be fit inside this x tau, because this width is very small, this width. So its total width should be in between this minus 2 plus t and a t. Okay, otherwise you can write here itself, you can write here like this. This point is minus 2 plus t and this is t. So I have chosen minus 2 plus t and t such that this total ht minus tau should be inside x tau, inside this x tau, because this width is 4, this width is 2, this can easily fit inside this 2, this x tau. So now I will multiply this 2, and this t is chosen such that this t is less than 4, this is 4, this t is less than 4, and this minus 2 plus t should be greater than 0. Okay, this is the 0, then only this entire signal will fit inside this x tau. Okay, now the limits are t greater than 2, from this to 2 less than t less than 4. This is one more case, 2 to 4. Then what happens, we have to multiply these two signals, x tau and ht minus tau, right? So this orange one is ht minus tau and this pink one is x tau. We have to multiply these two. Okay, so now I'm multiplying these two. If you want, I will draw again here. This is x tau, exists from 0 to 4, ht minus tau, this exists from minus 2 plus t and t. Okay, now we are multiplying these two, multiply this two. this one is 10, this one is 5. So this is the minus 2 plus t point, and this is the t point. This is minus 2 plus t, this is t. Okay, you will get signal only from minus 2 plus t to the 2. 10 into 5 will get 50. Remaining all cases, this is 0, this is 0. 0 multiplied by anything, 0. Okay, so the final step is we have to find out the area output. Okay, this y of t, area, yt is area is this width is 2. T minus of t, t minus 2 will get 2, and height is 2. 50 into 2 will get 100, and the limits are from, these are the limits, right? 2 to 4, 2 less than t less than 4. Right, this is one of the case, and the next case I will choose this. Initially it is here, okay, for t less than 0 there is no overlap. Next I'm shifting this to towards right side, this one. Next it came to here, next it came to here, right? Next again shift, again I have shifted this to towards right side. Next it came to here. Next again shift such that this t, this t value should be greater than 4 now. This is 4, this is greater than 4, and this minus 2 plus t, this lower limit, this is upper limit. This lower limit should be inside the x of tau, and this upper limit should be outside the x of tau. Okay, I have to choose like that. So we'll draw here that this, let us say this point is minus 2 plus t and this point is t. Okay, I've shifted this towards right side. We'll draw again. This is x tau 0 to 4. Now ht minus tau. I have chosen ht minus tau such that that signal is like this. This point lies within the x tau minus 2 plus t, and this t point should lie outside the extreme point of x tau. Okay, so this t is greater than 4, and this lower limit minus 2 plus t is less than 4. Okay, that is t is less than 6. T greater than 4, t less than 6. So 4 less than t less than 6, or equal to, you can put equal also, no problem, because it is a continuous time case. These are the limits. Now we have to do multiply these two signals. What you get after multiplication? X tau ht minus tau. So let us say this point is this one, minus 2 plus t, and this point is 4. For greater than 4 it is 0, 0 multiplied by anything 0, and for less than minus 2 plus t it is 0, so 0 multiplied by anything will get 0. So only you will get minus 2 plus t to 4, right? This minus 2 plus t, this is 4, and for the value is, this is 10, this is 5, you get 50. So area The next last point is area. To find out, this is the area. How to find out area? Area is nothing but yt, output. So this upper limit minus lower limit, you will get the length here. 4 minus of minus 2 plus t into 50. This 6 minus t, right? 4 minus of minus 6 minus t into 50. This is limits. The t limits are 4 less than t less than 6. This yt. This is one more output. Now in one more case, now if I shift further right side such that this point, lower limit minus 2 plus t is greater than 4. This is the 4. Okay, then this will come at, let us say, here. Let's say this point is here. Okay, so I'm shifting this. Okay, this is minus 2 plus t point. This is t. So this minus 2 plus t, this minus 2 plus t is greater than 4. That is t greater than 6. Is there any overlap between these two signals, ht minus 2 and xf2? So this is 0, right? 0 multiplied by anything, 0 in this case. Okay, so there is no overlap. Then you will get output is 0. You will write that here. So yt equal to 0 if t greater than or equal to 6. Okay, so this is the first one. Let us say this one. If yt less than 0, 0. And this is the second one. Yt equal to 50t for 0 less than t less than 2. And this is the third one. Yt equal to 100 for 2 to 4. And this is the fourth one. Yt equal to 6 minus t into 50 for 4 less than t less than 6. This is the fifth one. Yt equal to 0 for t greater than or equal to 6. I will write here all these things. So yt equal to 0 for t less than or equal to 0 and t greater than or equal to 6. This includes 1 and 5. Okay, list limits. And the second one is this 50 into t for 0 to 2. 50t for 0 less than t less than 2. Next, third case is constant. 2 to 4 we have 100. Third case 100. 2 to 4, 2 less than or equal to 3 less than or equal to 4. And 4 to 6, it is 4 to 6, 50 into 6 minus t. 50 into 6 minus t for 4 less than t less than 6. For t greater than 6, 0. So it is already included in this. Okay, this is the signal we have to draw. T. This is yt 0 and 2 into 4 and 6. For 0 to, for t less than 0, output is 0. Okay, this is 0. For 0 to 2, 50t. 50t means this is y equal to mx, line passing through origin. Yes. Slope is 50. Okay, slope is 50. Then this value is, so y by x. Y is, I don't know, y value. X is 2, right? X axis value 2. So we will get 50 into 2, this is 100. It is slope is 50. Slope multiplied with x, we will get y value, right? Next, 2 to 4. 2 to 4, it is constant, that is 100. This here 100 itself. And 4 to 6, it is 50 into 6 minus t. Okay. Substitute t equal to 6 here. Here t equal to 6, you will get 0, right? 6 minus 6, 0. So at t equal to 6, it is 0. And the slope is 50 into 6 minus 50 into t. This is yt, right? 300 minus 50t. What is slope? Y equal to mx plus c. M is minus 50. Slope is minus 50. Okay. Now, for t greater than 6, it is 0. This is the output yt. Okay. If you understand it, it is fine. If you don't understand it, you don't need to bother. Okay. So it won't helpful for your gate. Okay. We have shortcuts for this. You don't need to worry about this. You don't need about the graphical convolution. Okay. We have shortcuts for this. I will give you the shortcuts.